Hi, today we're going to look at adding and subtracting fractions where the denominators of the fractions are different. So on the whiteboard we've got a bunch of different diagrams. This is going to be an addition problem. Okay, so let's highlight in the first one we're going to have a third. In the second one we're going to have a ninth, and we want to see what that equals. Now, if we're just coloring in these two on the third diagram, we can see that the first third's going to be entirely taken up. The second part, we've got a little bit, but we don't know exactly how much we have, right? Because it's just divided into thirds. So if I was to write this out, we have a third and a bit. Okay. Now, the reason why I show it like this is because when we do fraction addition, you can't actually add fractions together when the number of parts, the diagrams are split into a difference. So if I write this out in our numbers, equals something, we don't actually know when it's in this current form. We can only add together the fractions when they have the same total number of parts. Otherwise, we don't know how much is sort of going to be in the extra little bit. So the way we need to do this is we need to cut this first diagram up so it's got the same number of parts as the second diagram. So to do that, each one of these segments I'm going to cut into 3. So it looks like that second diagram. So what we've done here is we had a third. Each of the segments we cut into 3, so the total number of parts we've multiplied by 3. And if we look at this first section, the total number of our selected parts we've also multiplied by 3. We've got 3 of those sections now. So over on the right, we're multiplying the selected parts by 3 as well. Now when we do that multiplication, we get 3 on 9. So this first fraction and this last fraction are equivalent fractions. We know this because we've multiplied a third by 1. And this is what we went over in our last video. Whenever we multiply something by 1, it doesn't change the value, but it can convert it from one format to another format like we've done here. So looking at this sum again, we can go, we've converted our third into 3/9. And we end up with 4/9 at the bottom. Up in our diagram, we've got 1, 2, 3/9 plus another 9th equals our 4/9, and that's how the addition works. It's exactly the same with subtraction. So if I had instead a minus sign here, I would end up with 2/9 because I have 3, I'm taking 1 away, I'm left with 2/9. So this is addition of fractions with different denominators. So you're always converting one of the fractions or both the fractions so they have the same denominator on both. So let's go through a couple of numerical examples. If I had 1 on 4 plus 1 on 8. Now one way you could show this is we're converting the denominator of the 4. So we're doubling the amount of parts because we want it to have 8 parts. But if we do that, we want to multiply a quarter by 1, so we're not actually changing the value of it. So we end up with this. If we do our multiplication first, BOMDAS, we get 2 on 8 plus 1 on 8, which equals 3 on 8, and we're done. Now, you don't necessarily need to show all of those steps. You could go from this stage straight to, if you're confident in that multiplication process, but I highly recommend at the start that you just do that to really ingrain the idea into your head what's sort of going on. Now there are some problems that can be slightly different and you can approach in a slightly different way. So I'll pop one of those up now. If we have, again, we've got a quarter and we've got an eighth, we can times the quarter by 2 on 2. This is one way we can do it. Which equals 4 and 8. Once we get to our final answer, we can then simplify it because you can see that we both have a 4 in common with the top and the bottom. So there's a few ways we can do that. We've gone through that in the last few videos, but that's going to end up equaling 1/2. So that's one way to do it. Another way to do it would be, instead of converting the 4 into an 8, we can simplify this fraction to begin with. So we can say, okay, now we have common denominators, and we would simplify again. Okay, so process a little bit different. Either way that you do it works well. I hope you enjoyed the video, and I will see you next time. This video accompanies a worksheet series which aims to develop conceptual understanding around fraction arithmetic. If you'd like to access the worksheets, click on the link in the description.